Hello everyone, this is Dr. J. Sundar Kumar, Assistant Professor, Department of Computer Science and Engineering, Kalinga Institute of Technology, Coimbatore. Today we are going to see about the topic of acting under uncertainty. Why this topic is important and where it comes. Actually, as you know that the probability reasoning. So in the why we need a probability in AI concepts. What is the purpose of probabilities in AI concepts? So because of the uncertainty, the probability is important because we have to find the predictions on time. So let us see about the uncertainty. What is an uncertainty? The uncertainty is the state of not knowing something completely. So we don't know completely. We don't know about what's uncertainty. In everyday life, it's everywhere. You don't know when if you don't know if it will rain tomorrow. So we don't know whether it will rain, it will be tomorrow, it will rain or not. Whether your bus will be come on time, we don't know about that. The job interview will go well, so we don't know about that. But uncertainty we have to know before the predictions. In AI, uncertainty is not an edge case; it is an default conditions. And AI system almost never be a complete perfect informations. It must be a reasons and act anyway. There are three fundamentally different kinds of uncertainties. So there are three kinds. One is an alliterative, episemic, ontologically. So with the help of this three uncertainty, you can see this ontology here. Here we are showing as unknown, and unknowns cannot be framed the probability space. Example, black spam events. So here we have the lack of knowledge can be reduced by gathering more data. So we have seen that unseen patients. So we are going for a flip coin. Okay, when we going for a flip of coin, we don't know what it will be. Maybe a head or it may be a tail. So based upon this, we are calling as we cannot remove. We are collecting the data more. So next we are going to see about why uncertainty is here. Yes. So before dealing with an uncertainty, it helps to understand why certain could be invaluable. A perfect sentence, AI could always choose the optimal actions. It won't be a never misclassify, never recommended wrong drugs, dose, never navigate a self-driving car into a danger. So if you know the if you know the certains, there is no issues in that. But certains is almost always out of the reach for the three instances. So what are the sensor are noisy? A camera pixels value is not an exact color of a space. It affects the lighting, lens quality, compressions. A microphone picks up the background noise. A medical scan can be in resolution limits. This we are calling as an certainty, right? The world changes. The training the data description of the past. The world at the inference time is subtle different. The spam filter is of 2020 emails will be an encounter phases it has never seen. The model approximate. Okay, these are some certainty disadvantages. So in this part we don't know about that certainty, right? This journey from the certain to uncertain, and it is in one way. You cannot recover the certains. You can only manage the uncertains better. Here you can see that uncertains acting under the uncertainty. The core problem in AI. Now we can arrive at the heart of it. And AI agents must take actions that affects the world, but it never knows the world is completely. It must decide what action is best given and what I believe right now. This is the central problems that nearly every major so we have to check nearly very major AI subfield graphically with an reinforcement learning. So with the help of this reinforcement learning, we can go for the uncertainty, the Bayesian inference, decision theory, and robust optimizations, and more. So what is an uncertainty? Is how it is functions. We will start from the belief states. Okay, we start from the belief states. that is p of world is equal to x for all of x. So it is in the form of a loop conditions, so it will be looping the uncertains to find a predictions. So in belief statements we have the two for, one is an chosen actions and observe the outcomes. So in chosen actions we have to find the action selections, then we will go for the world observations, then we go for the belief updates. So based upon this loop we can identify the uncertainty and we will solve the problems. So the core frames is the belief, actions, outcomes with the help of loops. With the help of this I can identify the uncertainty parts, right? Yeah. Next we are going to see about the why probability helps. Uncertainty representations, instead of saying it will rain or it won't rain, we say there is 70% of chance of rain. So what is this here is we are saying as in the form of probabilities. The decision principle choose the actions that maximize the expected utility, the average payoff the weightage by the probabilities. Here you can see that A star equal to an argument of max of A summation of P of, this is the probabilities. So where here we will start the probabilities, where A is an action, S is a possible state of the world, and U of A dash S is an utility, the benefit or cost of the action taken A in state. Here we have one example, one is an umbrella decisions. Imagine you are in Coimbatore and consider where to carry an umbrella. The forecast says 70% of rain. Utilities, it is in rain and you can carry the umbrella, so that is an utility is in 5. You stay dry. If it is in rain you won't carry the umbrella, utility is -10, you won't suffer. If does not rain you carry the umbrella, utility is minus and inconvenience. If does not rain and you won't carry the umbrella, utility is become 0, that is a comfort. So with the help of this I am calculating that expected utility of carrying the umbrella. So here 0.7 into 5 and because of 70% and balance is 30%, 0.3 into -3. So after calculating this one we will be getting this carrying the umbrella. Not carrying the umbrella we will getting the -1. The best choice is carry the umbrella because it is a maximum expected utilities. So with the help of this method we are calculating the probabilities of carrying the umbrella in the rainy seasons, right? Now we are going to see about the Bayesian inference. So in this method, the probabilities, when you are going for probabilities, there is an option called Bayesian inference. Is a probabilities method used to update the beliefs about the hypothesis when a new evidence is observed. So here there is a formula called Bayes Theorem which provide the mathematical frameworks for the belief updating. So what is the formula here is P of H bar E is equal to P of E by par dot P of H by E. So this is the probabilities. What is here, what is the values of P of H bar E is the posterior probabilities and E bar H is an likely likelihood, P of H is an prior, that is an initial belief before evidence, and P of E is an evidence, so overall probabilities of evidence. Then we have that behind inference in Bayesian inference, the follow the simple logics. One is an prior belief plus new evidence, we will get an updated beliefs. Start with the initial assumption, that is we are calling as prior, and observe the data is evidence, and update the beliefs accordingly is an posterior. So with the help of this we can solve the problem of an undefined or an unknown values. So here prior belief, that is we are in the form of a green color. This represents the initial understanding of or an assumption before seeing any new data. It is based on the previous knowledge. Evidence, so with the help of the evidence, that is in brown color. This data will we collect from the experiment or in real world. The integrations, this act as in the new informations we want to incorporate. Next we are calling as posterior belief, that is in the form of a blue curve. After considering the new evidence, the prior is updated to form posterior distributions, which is redefined belief that more accurately represented to the state of the knowledge. So with the help of this I can understand where my data, where can I can predict with the help of the probabilities. So we will go for a simple examples like a medical diagnosis. So consider the P of D is equal to 0.01. The tested accuracy is 0.99 and there is a negative. Okay. In disease, if a disease is positive, I will get 0.99. If positive, if it is negative, I will get 0.05. Okay. If the person that tests positive, what is the probabilities they actually have the disease? Using the Bayes theorem, the posterior probability will have much lower than 0.99 because the disease is rare. So insights, the even highly accurate tests or product misleading results when the prior probability is low. Why the Bayesian inference is important in AA? Because of the decision making under uncertainty, so which is help the robotics, automation systems and medical AI. Learning from the data, continuously update their models, beliefs as a new data arrays. Handling noisy data, so robots. So you can see that robots against the incomplete or uncertainty inputs. So these are the why Bayesian inference is important in AI. Next we are going to see about the application. So from the Naïve Bayes algorithms, the assumption is feature independence, widely used in spam detections and text classification. Next, Bayesian networks, that is in graphical models, a representation of probabilities and relations. Next we have the Markov chain Monte Carlo, which helps us to sample from complex probability distributions that are difficult to calculate directly. Then we have the real-time world domains like an fault diagnosis, weather predictions and risk analysis. So these are the application of an Bayesian inference. What are the key advantages? Incorporate the prior knowledge, updates the belief incrementally, works well with small data, provide the probabilities interpretations. What are the limitations? Require the prior probabilities, can be subjective, computationally expensive for complex models, independence assumption in Naïve Bayes may not be hold. So with the help of this topic, we can understand the uncertainty and how to solve with the help of the probabilities using the Bayes theorem, and we can understand how the evidence prior knowledge, posterior probabilities and likelihood will be calculated. So this will be useful for the uncertainty concepts in AI. The future of the Bayesian inference is handling the uncertainty and prior knowledge integrations, probabilistic modeling and regulations. These are the future of an Bayesian inference. And what is the difference between inference, Bayesian inference and frequentist approaches? Prior knowledge, that incorporates that prior knowledge about the hypothesis, update it as a new data is collected. Does not use the prior knowledge, focus only on the data available. Use of the data and prior knowledge are used together. Data alone is used to make an inference. Hypothesis testing, use the posterior probabilities of the test hypothesis, use p-values and hypothesis test. So what is interpretations? Provide the probabilities estimation of the hypothesis, provide the confidence intervals and the points of the estimates. What is the conceptions? The more intensity because of the need to update prior beliefs and compute posterior. Less computational demanding, as if the focus is on sample data and parameters estimations will be done. So this is the difference between Bayesian inference and frequentist approaches. So what is the advantages of an Bayesian inference is in flexibility, interpretability and data efficiency. What is the challenges? Computational complexity, like we will be working on the Markov chain problems. There is a more complex prior or large number of datasets in the form of an computational complexity. Choosing the prior, the result of the Bayesian models depends heavily on the prior knowledge we use. Then choosing the right prior can be tricky when we don't have much domain specific information. Scalability, so here the posterior distributions can be become more time consumptions as the data grows. This makes it challenging to make the model work efficiently on large data sets. So these are the challenges for Bayesian inferences. Okay, so thank you for the listening. Thanks.